We can see only rich
We are
people.
telling heat is a form of energy. So energy means the ability to do work. So it means heat is doing some work. Yes or no?
Yeah, ma'am, heat is doing some work, ma'am.
It does work. So can you give me an example?
Ma'am, like it heats a solid object, ma'am, like a solid object or liquid object.
Suppose take a pressure cooker. Okay, everybody have idea of pressure cooker, right?
Yeah, ma'am.
Mothers used to cook in pressure cooker. In pressure cooker, what we are doing, we are heating it. So we are giving energy to the pressure cooker. And due to heating, steam is formed inside the pressure cooker, right?
Yeah, ma'am.
Yes, if steam is formed, what steam is doing? Steam will?
Ma'am, it rises up, ma'am.
It rises the lid of the pressure cooker, right?
Yes, ma'am.
Can you see me
Yeah,
now?
ma'am.
So we can consider these an example as heat is doing work.
Can you see me now?
So example pressure cooker. Okay. Steam is formed within
Ma'am,
the
between the
cooker.
ma'am. And ma'am, when it touches the lid, ma'am, the vessel opens up.
When heated,
Yeah, ma'am. Ma'am, and when we touch the lid, ma'am, it makes a sound, ma'am.
and
Yeah.
when heated, it can lift the lid. It
Yeah, ma'am.
can lift the
Lift it.
lid of the pressure cooker.
Ma'am, can you see me now? Ma'am, I went to camera settings and enabled that option.
Okay. I can see you, Manish.
Can you see me now?
Yes.
Ashwath, we can't see you. Yeah.
Clear?
Yes, ma'am.
Yes, ma'am.
So heat is nothing but a form of energy, and energy is the ability to do work. So example, we can consider pressure cooker.
Yes, ma'am.
Done?
Yeah, ma'am.
Yeah, ma'am.
Shall I go to next slide?
Yeah, ma'am, you can.
So Rishikesh, again, your video is off.
Ma'am, it's not. That's the issue. Ma'am, I started my video, ma'am. It's coming
Your
like
camera
this.
is off actually.
Ma'am, now I really on, ma'am.
Mommy, on, but
Okay. Next,
the
coming
camera-
to the definition is temperature. So
Ma'am,
what
a
is
reliable measure
temperature?
of hotness or coldness is known as temperature.
So
Ma'am,
temperature we can consider as it is degree of hotness or coldness.
yes,
Yeah, ma'am.
ma'am.
A reliable measure of hotness or coldness.
Yes. So the
Yes.
degree of hotness or coldness of a body is measured in temperature. Okay.
Okay, ma'am.
So see,
Yeah, ma'am.
when two objects are kept in contact, like if I am taking hot body, which is like hot water I am taking in a beaker, hot water, and in other beaker I am taking cold water. Okay, so now what happens? The temperature actually flows. So where heat flows, so the temperature changes because temperature is measured of hotness and coldness. So the temperature changes and what flows? Heat flows. Always heat flows from hot body to cold body. So you can write.
Ma'am, this can be proven by an activity, ma'am. Ma'am, now
Yes.
you take hot water, ma'am, in a beaker and keep a metal spoon inside leave it for some 5 to 10 minutes, ma'am. After you touch the body of the spoon, ma'am, is going to become hot.
Hmm.
Ma'am, that shows that hot travels from a hot
Yeah, ma'am.
body.
Ma'am, ma'am, like in solids, ma'am, a spoon is a solid, ma'am. So conduction takes place, and conduction always transfers from a
Yes.
hotter end to colder end, ma'am.
Yeah, ma'am. Conduction can be only done in a solid, and convection can be done in all three of the states.
Okay. So what is the direction of heat, students? Heat always
Hot
flows
body
from,
to cold body.
yeah, hot
Hotter end to
object
colder
from
end.
hot
Hotter
body
end to
to
colder end, ma'am.
cold
Yes,
body.
yes, ma'am.
Okay.
Ma'am, one more thing, ma'am. Heated air goes up and cool air comes down, ma'am. This is called
Ma'am, that's why heaters are kept down and ACs are kept up.
Can you repeat again?
ma'am.
Ma'am, like that's why the heaters are kept down and the ACs are
Ma'am,
kept up.
Ma'am, can I tell one thing? Ma'am, ma'am, also the same works in the principle of ventilators, ma'am. Ma'am, ventilators like they'll be
They
in the
keep
ma'am,
up.
so that the hot
Because
air,
the cool
Yes,
air
ma'am.
would come
because the
and
hot air is light and rises up and goes out, ma'am, and from window the cold air enters, ma'am.
Yes, ma'am. Yes,
Yes.
ma'am.
Correct. Okay. So we are telling heat is flowing from hot body to cold body. So until which extent heat flows. So this heat flow stops as soon as the temperature is equal, like it becomes equal in both the
It stops
bodies.
flowing.
What?
Yeah, ma'am.
When it becomes equal, the heat starts
also be
flowing.
proven by
Yeah.
another activity,
Heat
ma'am.
flows.
Get cold water, ma'am. And ma'am, keep it in a sunny day, keep it outside, ma'am. After 2-3 hours, you'll observe that the bottle is hot.
Can you repeat again?
Ma'am, I told that take a cold water bottle and on a sunny day, keep it outside in your balcony for 2-3 hours. After you come back after 2-3 hours, the bottle would be hot.
Yeah,
That is
because
the
the
activity for
surroundings are very
radiation, no,
hotter
ma'am.
than bottle.
Yeah,
Ma'am, that
ma'am.
is the activity for radiation, no, ma'am.
No, you can consider heat flow in any case. Okay, heat flow
Okay.
Yeah.
stops as soon if you keep in a sunny day, then obviously the water becomes hot. Heat flow stop as soon as
The temperature of the body
temperatures
is equal.
becomes equal.
Becomes equal, yes, ma'am.
Okay, which is known as thermal equilibrium. So equilibrium, students, have you heard the term equilibrium before? So equilibrium always indicates no further reaction. Like nothing happens. Stopping of the reaction or stopping of anything represents equilibrium. Thermal equilibrium. Thermal means heat or temperature, whatever. So heat. So heat flow is stopped. So that condition is called thermal equilibrium. Understood?
Okay, ma'am. Okay, ma'am.
Now we will see the difference between heat and temperature.
Ma'am, like heat is energy and temperature is a degree of
Degree of
measurement of
coldness
hotness
of
or
the body.
coldness, ma'am.
Or of a body, Rishikesh.
Hotness or coldness, that much. It's enough.
That's only one difference you can give.
Ma'am, no, ma'am, still someone are there.
Ma'am,
Hmm.
heat has a
Ma'am,
source.
heat means only a hotness can come, ma'am, but temperature means hotness and coldness both will come.
Yes, ma'am.
Okay, so we will see the first thing is heat is
Ma'am,
form of energy which cause sensation of hotness and coldness, right?
Yes, ma'am. Ma'am,
Form
of
of energy. We will discuss one by one, students. Form of energy which causes hotness.
Ma'am, and we can also not tell, ma'am. ma'am, like, ma'am, by touching, we can't tell that the particular object is hot or cold, ma'am.
Okay. Next, coming to temperature, the degree of measure of degree of hotness or coldness. So measure. So whatever the cause, the heat or cold the heat is causing, so that particular measure is called temperature. Measure of hotness or coldness
Cold of a
of
body.
a body. Okay. So
Ma'am,
coming to the next point, heat energy is the cause.
Ma'am, should we take only the body or can we take any object also, ma'am?
Anything.
Yeah,
Ma'am, but
ma'am.
you wrote body, right?
Body, nothing but, see, body means not human body.
Yeah, it can be any body, like rabbit's body. It can be.
It can be any body. It can be an object as well.
Yes, ma'am. Even it
Water
is.
body.
Ma'am,
Even
it
the
can be
water
an
body.
abiotic body also, ma'am.
Biotic and
Abiotic body.
abiotic factors all comes under this category.
Yeah, ma'am.
Okay. So whereas temperature is the effect.
Okay, ma'am.
Ma'am, another one is its unit, ma'am. Temperature has it can be measured in Kelvin, centigrade, and Fahrenheit, ma'am. And heat it can be measured.
Yes, very good. Very good. It was a good difference.
Yes, ma'am.
Okay. So
Ma'am,
units
can I tell
are
one difference?
units, like it is measured in. Yes. After this,
It is
tell me.
used
After
measured.
completion of this point, then tell me the next
Ma'am,
bit.
it's measured in
In
units.
joule, as it is energy, right? We can measure in the
Well,
form of joule or
12
calorie.
calories, ma'am.
Yeah, ma'am.
Whereas temperature is measured in
Measured
Kelvin,
Kelvin,
Celsius,
Kelvin, Celsius, and Fahrenheit, ma'am.
Fahrenheit.
Ma'am, actually,
Fahrenheit.
Celsius scale was discovered by Anders Celsius, ma'am.
Yes, ma'am.
Yes.
Kelvin scale was also.
Ma'am, and also, ma'am, ma'am, the strange thing here is he fixed the freezing point of water as 100 degrees Celsius and boiling point of water as
100
0
and
degrees Celsius, ma'am.
no, Rishikesh boiling point is not 0 degrees Celsius. Freezing point is and boiling point is 100 degrees.
Anders
He
Celsius
told.
kept like that.
Yeah. Okay. So next point is heat is measured with which
Ma'am, joule, ma'am. Ma'am.
Joules or calorie.
No, I'm not asking the units. Like temperature, we will measure temperature with the help of thermometer, right? So what
Yes,
is the
ma'am.
instrument used to measure heat?
Ma'am,
Ma'am, the instrument used to measure heat is,
Celsius.
ma'am, like not
thermometer.
Celsius, right?
Colorimeter, ma'am.
Yes, calorimeter is
Yeah,
the
ma'am, caloriometer, ma'am. Ma'am, caloriometer is used to
Ma'am,
measure.
ma'am and joule, ma'am and it is, ma'am and heat is represented.
Ma'am, if all people turn on the camera, we can do justice who is using Google and who is not.
calorimeter
if
is used to measure.
If they use Google, then I can also show you the proof that I'm not copying this. Seriously.
I know you all not, but others are. Like some people are here. Because people don't know what heat and temperature.
These students, it is recording and what you're speaking. So calorimeter is used to measure heat.
Yes, ma'am.
Yes, ma'am.
Ma'am,
Whereas
temperature.
thermometer is used.
Ma'am, thermometer is used to measure temperature.
Yes. Then what points you can write? What else? Heat energy always flows from.
Heat is represented as Q and temperature is represented.
Yeah, T. So represented or denoted by. We will write as denoted by Q. Small q or it can be capital Q sometimes. Okay. Temperature is denoted by P.
T, ma'am.
Okay. Next, we can write that heat energy always flows from higher temperature to lower temperature.
From hotter end to colder end.
Yes. So heat always flow from
flow from cold body to
hot,
cold body.
Hot end to colder end. Hotter end
okay,
to colder.
hotter end to colder end.
Ma'am, you can say body, right?
Yes, you can tell as body as well. Okay. Whereas temperature, it depends upon the kinetic energy of the molecules.
Yes, ma'am.
So more the movement of the particles inside, so it shows the more temperature, right?
And like rises when heated and falls when cool.
Yes, yes. So when it is heated,
Yeah,
the
ma'am.
molecules moves very fast. So it depends on
Yeah.
the average
Ma'am,
kinetic
and
energy.
ma'am, if we eat anything, ma'am, like any food or like that, we may, ma'am, like we may see a light movement. Ma'am.
Even we, right?
Yeah, ma'am, even we, ma'am, like sometimes, ma'am, the molecules in the solids vibrate to the energy of the heat.
Yeah,
Ma'am.
yeah. Actually, they start moving. They show vibrations, and due to that,
Ma'am,
temperature increase.
ma'am, we can prove this, ma'am, like we can prove this by an activity, ma'am. We have to take an iron rod and we have to fix a wax
We will
to it
discuss
and we have to
activities
heat it, ma'am.
later. We will discuss activities later. Okay. So let us start the introduction part. So next, measurement of temperature. So temperature, we discussed that we will measure with thermometer, right?
Yes,
Yes.
ma'am.
So how the thermometer will be? Thermometer is an instrument which is used to measure temperature. And if you see a simple thermometer, how it will be, students? It will be long. I think I can show you.
Ma'am,
Hmm.
ma'am, can you repeat it again what you said?
Yes, yes. Thermometer. Can you see here thermometer, how it is?
Yes, ma'am.
So it is generally thin.
Ma'am, and laboratory thermometers are way bigger, like triple or 4 times the size.
Yeah,
of
they are like sizes are different. It depends on the experiment
4
that
or
you are
5 times
performing.
the size of this.
Okay, so the thermometer generally it is long, narrow, and uniform.
mercury in
All
it.
it is uniform. Uniform glass tube.
Ma'am, and has mercury in it.
Yes. At one end you can see a glass bulb. Okay,
Yeah,
right?
ma'am, we can see a glass
It
bulb.
has
Ma'am.
mercury, right?
At one end.
Ma'am, that bulb absorbs the heat and the heat is absorbed by
Yes.
mercury, ma'am. Which
We can see the.
Ma'am, it has a
glass-
kink also, ma'am.
Ma'am, it even has a kink.
kink, ma'am.
Kink,
Ma'am,
ma'am.
the kink
Ma'am, kink
prevents
helps
the
to,
outflow
ma'am,
of mercury.
because of the kink, it doesn't fall. Mercury
Fall
won't fall
back, ma'am.
easily. Like
Okay.
we could check it accurately in
Okay,
using of
correct.
kink.
Ma'am, after after using, you have to jerk it off, ma'am.
Yes, we have to jerk it out. Okay.
Ma'am, before using.
Along the total length, you can see there are graduations. Graduations means like scales you can see, right?
Yes, ma'am.
Yes. In that, generally those are called lower fixed point, upper fixed point. Okay. So lower fixed point. What is lower fixed point? Lower fixed point means the temperature at which ice melts, and upper fixed point is the temperature at which water boils. Lower fixed point means temperature.
Ma'am, and it is even like 35 Celsius to 42 Celsius, ma'am.
Lower fixed temperature, temperature at which ice melts. And upper fixed means?
Where the water boils.
Yes, the temperature where the water boils.
What boils, ma'am?
At which water boils.
Ma'am, this is a clinical thermometer.
Yes.
Ma'am,
Like
but
we will
really
do
we have to
this in
not
the
boil the
laboratory.
water to check
Ma'am,
the
it's like
opposite
it
point,
ranges
ma'am.
from 35 Celsius to 42 Celsius.
Which
Ma'am,
one?
and then,
Clinical
ma'am, the
thermometer.
clinical, ma'am, and also 94 degrees Fahrenheit to 108 degrees Fahrenheit, ma'am.
Okay, that we will discuss among the types of thermometers. Okay,
Ma'am,
this is
and
not the
also-
clinical. In the clinical, you can see a nib here. So even we can use.
Ma'am? Ma'am?
Huh?
Ma'am, also, I want to tell one thing, ma'am. Ma'am, it only ranges to 35 degrees to 42 degrees Celsius because the human body temperature is 37 degrees, ma'am. Celsius and the human body doesn't go below 35 degrees Celsius and above 42 degrees Celsius, ma'am. That's why.
So not all the clinical thermometers, only some clinical thermometers are made in that manner. Not all.
Okay. Ma'am, and also 37 degrees Celsius in Fahrenheit means I think it's 98.6 degrees, ma'am, Fahrenheit.
We will do that. How to convert. Okay. Next, there are how many kinds of temperature scales? Like we have discussed. First one, types of temperature scales.
Ma'am, like Celsius,
Yes.
Fahrenheit.
So among that,
Ma'am, and Kelvin
Celsius,
also, ma'am. Kelvin,
Celsius scale,
Fahrenheit, and Kelvin.
Fahrenheit
And
scale,
Fahrenheit scale and Kelvin scale.
Kelvin
Ma'am.
scale.
Ma'am, and the Kelvin scale is the standard.
Ma'am, these are the SI
unit of
units of
heat,
the
ma'am.
temperature.
Yeah, ma'am, it's SI unit.
Student,
Ma'am,
this you have already completed.
No, ma'am, we have not completed. No.
Then
Ma'am,
you
for us,
know,
this
but
lesson is
remaining
completed in
students, they
school.
has to learn, right? If you are telling and I am telling, they will be confused with everything. Okay, Celsius scale, coming to the Celsius scale, this is also called as centigrade scale. So centi means, what is the meaning, students? What is the value for centi?
100, ma'am.
100 is
10,
20.
10.
So from the name itself, you can see that there are 100 divisions in it. How many
Yeah, ma'am.
divisions? 100
I'm
divisions.
100.
So
Ma'am,
where
10,
100
so
is
it's 10.
Ma'am, it's 10
between
divisions.
what?
10 divisions, ma'am.
No, Ashwar, deci means 10, centi means 100.
Will you listen, guys? 100 divisions between the upper and lower point. So we have discussed that what is upper fixed point and lower fixed point. Among upper and lower fixed point, you can find 100 division between the upper and lower standard points or fixed points. Okay. And this scale was introduced by a Swedish
Celsius.
astronomer, Celsius. His name is Celsius.
No, ma'am, under Celsius, no, ma'am.
Yes, yes. Introduced by, he is from Sweden. What is his name?
Under Celsius.
Okay, based on his name, the Celsius is given to that particular scale.
Yeah, ma'am.
Okay.
Ma'am, what is great invention?
So each line, each division, we will be calling it as centigrade. Okay, or degree Celsius. Okay.
Yeah.
So units are degree Celsius. We will represent like this. There are some more sensitive thermometer students under Celsius which have generally 200 divisions in it. Okay. So in that, if 100 divisions are there, each division we are considering it as a degree Celsius, right?
Yeah, ma'am.
If 200 are there, then you have to consider each division as half degree.
Ma'am, so 2 degrees has two degree, two
Yeah,
as 1
two
degree
divisions
Celsius.
as one, each division as half. Understood?
Yeah, ma'am.
In some
Ma'am, if
sensitive,
500 on there.
no, not there. In more sensitive thermometers, you can find only 200 degrees Celsius.
Okay, ma'am. got
Okay.
it, ma'am.
Next, coming to the Fahrenheit scale.
Ma'am, actually, after writing, can you wait 1 second, ma'am?
Yeah.
I'm writing, ma'am.
So from the beginning you need, or else this one?
Ma'am, this one only.
Okay. So you can write that point also. More sensitive thermometers have 200 divisions and each division is equal to half degree Celsius. And before that, for 100 degrees Celsius, we have to write each division is equal to 1 degrees. Each division on each division on this scale is called as 1 degree Celsius. Understood?
Yes, ma'am.
So let me know after completion, guys.
Okay, ma'am.
Ma'am, done, ma'am.
Okay.
Yes, ma'am, finish.
1 minute. So let me show you. Can you see here how Celsius and Fahrenheit? First see the Celsius, then we will discuss about Fahrenheit. Okay. In Celsius thermometer, you can find the lower fixed point at 0 degrees where presence of ice or water freezes. Okay, that means ice melting point, and higher is the water boiling point at 100 degrees. This is the lower fixed point and this is the higher fixed point. In the middle, the normal body temperature is measured, which is 37 degrees Celsius. Okay. Clear?
Yes, ma'am.
Next, coming to Fahrenheit thermometer, you can see in case of Fahrenheit, 32 degrees Fahrenheit is the lower fixed point where water freezes. How much? 32 degrees Fahrenheit. Higher is 212 degrees Fahrenheit where water boils, and the normal body temperature is, in terms of Fahrenheit, 98.6 degrees Fahrenheit. So if thermometer is there in your home, you can check in it whether the temperature is giving Fahrenheit or Celsius. Okay. Actually, I have this thermometer, Fahrenheit thermometer. Clear? Yes.
You can go.
Ma'am, which version of is this, ma'am?
Which one?
SAP, ma'am.
What?
Ma'am, which version app is this, ma'am?
My app?
Yes, ma'am.
No idea, students. So I think
Ma'am, yesterday, sorry, day before yesterday, you showed it, right, ma'am?
yes. It was yeah 3.1.43735. It is 2018 and it is a licensed one.
So, ma'am, you have to pay for buying it.
Yes, you have to pay. Fahrenheit. So you can see the Fahrenheit, right? What is the lower fixed point? It is 32 degrees Fahrenheit and upper is 212 degrees Fahrenheit.
Yes, ma'am.
Okay, we will be writing here. And this Fahrenheit scale was discovered by Fahrenheit. The scientist name, the scale was. The students, you also enter like discover something and keep your name by Fahrenheit. Okay. So
Ma'am, wait, ma'am. So, this scientist's first name was Fahrenheit. Ma'am?
what the name?
Ma'am, so the name of the scientist who created Fahrenheit is Fahrenheit. First name.
No, the name is Fahrenheit only.
Yeah, ma'am.
He is Daniel Fahrenheit actually.
Ma'am, so the last name is. Ma'am, the last name is.
Last name is from its name only Fahrenheit was invented.
I know, ma'am, but I'm telling ma'am that if I go to Google right now and write Fahrenheit, I'll see the whole Fahrenheit family.
Students. So you learn from Google only. See, Google was, I can do in Google, like I can upload, I can create, I can edit. Isn't it?
Yes, ma'am. Ma'am, let's continue.
Okay. So this scale represents, so what are the points, students? Readings, 32 degrees Fahrenheit. This scale represents 32 degrees Fahrenheit
Water
with
freezes.
melting of ice.
No, ma'am, freezing of ice.
Yeah, that's what. Okay, melting and freezing, both are same terms.
Okay, ma'am.
Or else, see, it is showing above which freezing takes place. Or else below which, sorry, above which melting takes place, below which freezing takes place. You can consider this as the one. Here also, above which vaporization or below which. So this is the standard one, right? In that manner. So 32 degrees Fahrenheit, melting of ice. And 212 degrees Fahrenheit, steam point, isn't it?
Yeah. Yes,
So
ma'am.
where
Yeah,
water
ma'am.
boils means where steam is formed. Okay. So below 32 degrees, if you see, it is marked as 0.
Yes, ma'am. 0 Celsius. The water just freezes and boils at
Yeah.
100 degrees.
Yeah. So total in this, how many divisions, students? Total 100 divisions in this case. But in this case, how many divisions?
Ma'am, 212.
In this, total from 100 to 0, there are how many divisions? 100 divisions. In this, how many divisions? 180 divisions.
Okay, ma'am.
Each division is called as Fahrenheit. Each
Okay.
line, which is nothing but the division, you can see right here, which is called
Yes.
Fahrenheit. The length is divided into how many parts?
Ma'am, the length
180 equal parts
equal
or
parts.
180 equal division.
Yes, ma'am.
Each division
Ma'am, each
is
division.
called one Fahrenheit, 1 degree Fahrenheit. Like 1 degree Celsius in case of Celsius scale and 1 degree Fahrenheit in case of Fahrenheit scale.
Yes, ma'am.
Okay, so where this is used, this Fahrenheit scale, generally we will use the Celsius one in our home, right? For measuring
Yes,
the
ma'am. Ma'am,
fever
most
and for measuring
ma'am,
body temperature. So
yes, ma'am.
Fahrenheit scale is widely used for meteorological and clinical purposes.
Okay, ma'am. Ma'am. Okay, ma'am.
Widely used for meteorological and clinical purpose. Okay. Now, how to convert Celsius to Fahrenheit, like relation between Celsius and Fahrenheit. So this is the formula, very important to you in solving numericals. So better to learn this formula, relation between Celsius and Fahrenheit scale. So it is C by 5 is equal to F minus 32 by 9. C means the Celsius degree.
Ma'am, 5 by 9, ma'am.
What 5 by 9?
Sorry, ma'am, you can continue, ma'am.
C is Celsius temperature. F is Fahrenheit temperature. C by 5 is equal to F minus 32 by 9. Okay, can we do a problem now?
Yes, ma'am.
Yes.
Yes, ma'am. Yes, ma'am. Yes,
So
ma'am.
the question is convert 5 degrees Celsius to Fahrenheit. What can we do? What is given to us? Given as is C. So C is given. So I can write 5 here, right? 5 degrees Celsius is by 5 is equal to F minus 32 by 9. I have to find F. So what can I do, students? What can I do?
Ma'am, you can cancel 5 and 5.
Yes. Then 9 comes here. So 9 is equal to F minus 32. Isn't it? On cross multiplication.
Yes, ma'am.
So I need F. F is equal to 9 plus 32. Plus, minus 32 goes to the other side and it becomes plus 32. So that gives you how much?
Ma'am, which gives us around, ma'am, 41, ma'am.
41 degrees Fahrenheit.
Fahrenheit.
Okay. Clear? Now, what is the normal body temperature in case of Celsius, students? 37. Can we convert this to Fahrenheit to check whether we are getting 98.6 or not? Yes? Yes or no?
Yeah, ma'am.
37 degrees Celsius to Fahrenheit. How many Fahrenheit? So formula is C by 5 is equal to F minus 32 by 9. So C is how much given? 37 by 5 is equal to F minus 32 by 9. Tell me, 5 ones are how many times? 5 sevens are 35. 2 left, 7.4.
7.4, ma'am.
Then on cross multiplication, 7.4 into 9 is equal to F minus 32.
Yes, ma'am.
Isn't it? How we will do cross multiplication? In this manner. Then F is equal to how much? 7.4 into 9 is? Now you won't do calculation, you'll search in Google, right?
Ma'am. Ma'am,
F is how much?
Ma'am, 6.79.
7.6, right? But
Yeah, ma'am.
and minus 32 is there here. F minus
Yeah,
32
ma'am.
is equal to 66.6. Then I need only F. What can I do?
Ma'am, F equals 66.6.
Ma'am, 66.6 plus 32, ma'am.
That gives you.
Rishikesh.
Ma'am, it's 98.6.
Yes, ma'am.
Do
Ma'am,
we
it's
get the same? Yes, 37 degrees Celsius is equal to 98.6 Fahrenheit. Yes or no?
Yes, ma'am.
Then we will
Yeah.
check 32 degrees Fahrenheit is equal to 0 degrees Celsius or not. Shall we check? Yes.
Yes, ma'am.
So next, what it is given? 30. (32 degrees Fahrenheit equal to how many Celsius? How many degrees Celsius? Tell me what is the formula. C by 5 is equal to F minus 32 by 9. This time what is given to us? Fahrenheit is given. I have to find C. 32 minus 32 by 9. So these both cancels and what left? What was left, students? You're doing?
Yes, ma'am. Ma'am, this cancel, ma'am. It becomes 1, ma'am. 0, ma'am. 0, ma'am. 0, ma'am. 0.
Which becomes 0.
Ma'am, 32 minus 32 equals 0.
Yes? 0 degrees Celsius. Do we get this? Yes or no? Are you there? I can't hear you guys.
Ma'am.
So next question, will you do for me? 212 degrees Fahrenheit is equal to how many Celsius?
Okay, ma'am.
What, ma'am? I just went out.
212 degrees Fahrenheit. 2 Celsius.
Ma'am,
I got it, ma'am.
How much?
100 degrees Celsius.
100? So did
Ma'am,
you?
because ma'am, because you showed a picture, ma'am, in that.
I showed, but I'm
2
asking you to do.
yes, ma'am. You have to actually solve it, ma'am. Formula equals, ma'am. C by 5
5 is equal to
F.
F
Ma'am,
minus 32 by
Ma'am.
9.
Ma'am, the answer is 100 degrees Celsius, ma'am.
Yes. So C we have to calculate.
yes,
C
ma'am.
by
C by
is
5
equal
equals
minus
212
12 minus 32 by 9. So
Ma'am,
C
now
by 5
we
is
solve
equal to
the
180 by 9. So
Ma'am,
9 ones are 9 twos are 0.
Ma'am, ones are, 5 ones are,
So it
and
is
5
cross multiplication. We can't do direct 5 into 20 cross multiplication, right?
5 into 20 is 100.
100, ma'am.
So it
Ma'am,
is
but
100
ma'am,
degrees Celsius.
yes, ma'am. Yes, ma'am.